In this question, we're first told that the random variable x has a normal distribution where the mean is 30 and the standard deviation is 5. The very first thing we should do before we start on anything is to define that distribution. So it's a normal distribution. X follows a normal, and then we put in the two parameters. So mu is 30 and sigma is 5. We're asked to find the probability that x is less than 39. So the probability x is less than 39. What would that look like on the diagram? This will be our sense check. So less than 39 would be this area that I've shaded. We're expecting a large probability. When I say large, I mean bigger than 50%. So let's use our calculator to evaluate this answer. We can make use of the NCD function on our calculator. We need a minimum and a maximum. So we're going to choose an arbitrarily small value, negative 1000. That would be all the way off in the left tail. The maximum we're interested in is 39. The standard deviation is 5 and the mean is 30. So we calculate and we get an answer of 0.9641. So just like we anticipated, this was a large probability. Moving on to part B, we're asked to find the value of D such that this statement is true. We want the probability that x is less than D to be 0.1151. Well, let's see this on the diagram. So the probability that is less than D, 0.1151. To find this unknown value D, I hope we recognize this situation. We can use the inverse function. So the inverse function on our calculator will tell us a real world value or a value for x if we knew the probability to the left of that value, the probability that it was less than that value. So we can find D with the inverse function. D equals inverse 0.1151. Then we need the standard deviation and the mean. In our calculators, we get the answer 24. So D is 24. Part C asks a similar looking question, but we're told the probability that it's greater than E is 0.1151. Let's add E to the diagram. Let's not forget, we've been given the probability greater than E. So if I want to use the inverse function, I need to know how much is below. 1 minus 0.1151 gives us 0.8849. So if I use the inverse with 0.8849, the standard deviation of 5, and the mean of 30, that will give us the value for E. And here we go, E is going to equal 36. Okay, just stopping right here and looking at the diagram, I hope we can recognize there was some symmetry we could have made use of. Since the probability below D and above E are the same, I can deduce that D and E are the same distance away from the center. They're the same distance away from 30. So if D was 6 less than 30, E is going to be 6 more than 30. So whether we use the calculator technique or we use some intuition, actually it's more than intuition, it's an understanding of the normal distribution. The deep understanding would save us some calculation time. Okay, on to part D. Part D wants us to find the probability that we're in between D and E. Well, once again, looking at the diagram, I know it's the unshaded region. So it could really just be 1 minus 2 sets of 0.1151. And there we get an answer, 0.7698. Some students may not recognize this, especially if they haven't produced a diagram, and might go the longer way around of actually calculating using the NCD function. So the NCD for the unshaded region, the minimum we're interested in is 24, maximum is 36, standard deviation and the mean, and we get an answer, not as accurate of an answer, we get 0.7699. But both of them are the same to 3 significant figures. In this question, we're told that the measure of intelligence